Every app you've ever opened is a lie. It doesn't own the CPU. It doesn't own RAM. It doesn't even own the screen. There's a piece of software running beneath everything. Invisible, ruthless, and in complete control. This is the operating system. At the center of every OS is the kernel. It's the only software that runs in privileged mode, direct access to hardware. User programs live in a sandbox. They request resources through system calls. The kernel decides who gets what and when. Without it, every program would fight over hardware and the whole system would collapse. When you launch an app, the OS creates a process, a running program with its own memory space, CPU registers, and execution state. It lives in one of 5 states: new, ready, running, waiting, or terminated. At any moment, your computer has hundreds of processes, but most CPUs only have a handful of cores, so only a few can actually run at once. The OS has to manage the rest. The CPU scheduler decides which process runs next. Round robin gives every process a fixed time slice. Fair, but not smart. Priority scheduling runs urgent tasks first, but low-priority processes can starve. Multi-level feedback queues adapt dynamically. Interactive tasks get more CPU, long batch jobs wait. Modern schedulers like Linux's completely fair scheduler use a red-black tree to track virtual runtimes and always pick the process that has run the least. Every process thinks it owns all of RAM. That's virtual memory. The OS creates an illusion. Each process gets its own virtual address space, starting from 0. A page table in the CPU translates virtual addresses to physical ones on every memory access. Pages not in RAM live on disk. Access one and you get a page fault. The OS pauses the process, loads the page, and resumes it. The process never knew anything happened. This is why you can run more apps than your RAM should allow. Files are an abstraction. On disk, everything is just blocks of bytes. The file system creates the illusion of a hierarchy: folders, names, paths. Each file is tracked by an inode, a data structure holding its size, permissions, timestamps, and the disk block addresses where its data lives. When you delete a file, the OS removes the directory entry and marks the inode free. The blocks aren't wiped. The data is still there until something else is written. That's why file recovery tools work. When multiple threads share resources, chaos follows. 2 threads reading and writing the same variable at the same time produce a race condition. The result depends on who goes first, and it's undefined. Mutexes lock a resource, so only one thread can access it at a time. But locks create new problems. If thread A holds lock 1 and waits for lock 2, while thread B holds lock 2 and waits for lock 1, neither can proceed. That's deadlock. For conditions must all hold: mutual exclusion, hold and wait, no preemption, and circular wait. Break any one and deadlock is impossible. The OS is the most important software you never think about. Every abstraction we've covered, the kernel, processes, the scheduler, virtual memory, the file system, concurrency, exists to solve one problem: sharing limited hardware safely between many programs that don't trust each other. The next time your computer runs 40 apps without crashing, that's not magic. That's decades of systems engineering working perfectly, invisibly, right beneath your fingertips.